Hi, good Monday morning. I hope that you had a lovely week off for spring break. Today is Monday. Ooh, I should look up the date. April 12th. Oops, 4. Hope you guys had a great week off. We're going to get started and continue working in our Unit 8, looking at volumes. So these are all about the formulas. All right, so a few definitions. I know we talked about these the week before spring break, but just want to clarify. So we have a prism. It's a solid object. It has identical ends, flat rectangular faces and bases, and the same cross section all along its length. Meaning that if I have some sort of a prism, the top and the bottom, or the front and the back, or the left and the right, it just depends. The bases are the same. And if I were to cut along different slices of it here, those cross sections, it would be the same. Now, a pyramid is a solid object that has one base and 3 or more triangular faces that meet at a point. So here is a pyramid that's on its side. I've got my base down here and my point here. This is also a pyramid. I've got my base down here. They're meeting at this point. This one, kind of hard to tell, but I have a pyramid because it meets at a point. Okay. All right. So the volume of a prism is B times H. B being the area of the base. Now, in any prism or pyramid, it's all about the base. The shape of the base determines what formula I use for the area of the base. So the most common area of the bases that we use are bases that are squares, rectangles, and triangles. These are the most common bases, but I can have a base that is any polygon. I can have a hexagon, I can have an octagon, I can have a pentagon, I can have a parallelogram, I can have a trapezoid, I can have a kite, but these are the most common shapes that we have. So the first question to ask yourself when finding the volume of a prism or pyramid is, what shape is the base? So let me do just a couple drawings for you. I like to, when drawing these, draw out the base. So if I have some sort of a rectangular base, okay, not the best rectangular base that I have here. And then I have another rectangular base. So it's slanted because I'm looking at it 3-dimensionally. And then I can connect my edges. Okay, ooh, that is the worst drawing I think I've ever done. So what I also like to do is draw the ones that are in front and then connect them. This is probably a much better drawing here. Oh, can't see it. So my base could be the bottom, the top, it could be the front, the back, it could be left and right. But in a prism, in any prism, the bases are going to be congruent. And then you have faces that go around the bases. So they're essentially what connect the bases. If you have a rectangle or a square, it really doesn't matter which side you make the base, but if I have a triangular prism, it does matter that I make the triangle my base. So in a prism, you will never have a triangle as a face. The faces will always be rectangles. So if I have a triangular prism, then my base is some sort of triangle, like a wedge of cheese. So in this case, the triangle has to be the base. Sometimes the bases are the top and the bottom. Sometimes you can rotate them so that the bases are looking at you. It just depends on the picture, okay? But the volume of a prism is the area of the base, whatever shape of the base that I have, times the height. All right, so on a pyramid, the area of the base is not the same, or sorry, the volume of a pyramid is not the same as the volume of a prism, because if I have the same base shape, I can fit 3 pyramids into 1 prism. So the volume of any pyramid is 1/3 area of the base times height. So B is still area of the base, same height, but I can fit 3 pyramids into 1 prism. So if I have 2 figures that have the same base and the same height, 3 pyramids will fit in 1 prism with the same measurements, right? So just some formulas. So something to note, not so much with, well, we kind of go to prisms. If I have an oblique prism, like this would be an oblique prism where it is not straight up and down, I want my height to go from one edge to the other and always be perpendicular. So if I slant something, then I want the height to go from base to base. In a pyramid, I want my height to go from the top peak, and I want it to be perpendicular to the base. So these are all heights that come from the top peak, perpendicular to the base. Hard to see with it being 3-dimensional, but if I were to have a height that's on the outside of the face here, this is what I call the slant height. And it will always be longer than the actual height, because I could actually then make a right triangle, and this would be my hypotenuse. So if the height is on the outside of your pyramid, we want to find the height that actually goes inside from a pyramid and perpendicular to the base. Okay, so I've got some examples that I'm going to work for you. Feel free to pause the video, draw some pictures. I also have these notes posted on Canvas. So for problem number 1, we have a prism. So volume is going to be equal to the area of the base times the height. And my base is not the bottom here. My base is the right triangle. So you always want to identify what is the base. So the base is a triangle. So to find the area of a triangle, so I'm going to use parentheses for my area of the base. My triangle formula is 1/2 base times height. So in this base triangle, the base is 8, the base of the base is 8, and the height of the base is 6. So this is all about the base. So the base of the base is 8, the height of the base is 6. So this is 1/2 times 8 times 6. And then this height is the height of the whole prism. The height of the whole prism connects the 2 bases. So that's going to be 9. So I need 1/2 times 8 times 6, that's the area of the base, times 9. I'm going to find my calculator and put it in a super special hiding spot. Here it is. All right, I like to just type all this stuff in. So I have 1/2 times 8 times 6 times the height, which is 9. There's my volume, 216. And I always need to include my units, and my units will be cubed because this is a meter, this is a meter, and this is a meter. So it's meters cubed. Your volume will always be meters cubed. So my volume is 216 meters cubed. All right, looking at my second example, this is also a prism. So I'm going to use volume is equal to the area of the base times the height. The base is also a triangle. So now my base is on the top and the bottom. So my volume is going to be equal to area of the base, which I'm going to find the area of the base. It's a triangle, 1/2 base times height. So in this triangle, the base is 3, the height is 4, or I could do the base is 3 and the height is 4. So in a triangle, when you find the area, the base and the height have to be perpendicular. So I'm just going to do 4 times 3. And then the height of the entire prism, the height of the entire prism is always the distance between the 2 bases, which is 2. So if I plug this whole thing in, it will give me my volume. So, oh dear. 1/2 times 4 times 3, there's my area of the base, times 2, ends up being 12. So my volume here is 12, and then I have my unit, which is inches cubed. All right, area of the base times the height. Got another prism here for problem number 3. In this problem, my base, so it is a prism, and my base, so volume equals base times height, is a rectangle. So I can't see the insides of this, but I can use this as my base. So the area of the base of a rectangle is length times width. In this figure, my length is 7.5, my width is 3.2, or my length is 3.5 and my width is 8.5, 3.2, 8.5. It doesn't matter which one you use. We're going to use those two sides of the rectangle. So 8.5 times 3.2, this is the area of the base, times the height of the entire prism, which is going to be the distance between the bases, so times 13.7. I'm just going to type this in. 3.2 times 13.7. So anytime we have decimals, we're going to round to 2 decimal places, and this gives us 2 decimal places. So 372.64, and then feet cubed. You always use your unit cubed. All right, we're now looking at some pyramids. So with my pyramid, it's usually much easier to find the shape of the base. It's opposite the point. So here I have a pyramid, and I'm going to use 1/3 area of the base times the height. So it's the same as if I had a prism that had a height of 10 with a square on top, like I have a square on the bottom, but 1/3. So 3 of these will fit a prism with the same volume. My base is a square. So you do not see 90-degree angles. We're going to take some liberties. I will not give you a parallelogram as a base. Like it'll be either a square or like this last one, we have a rectangle. So my volume is equal to 1/3. Here's the area of the base. So the area of the base, since I have a square, my 2 sides are 5 and 5. And then my height has to go inside and be perpendicular. So here's my height. It is 10. All right, so I'm going to type this in. So 1/3, 5 times 5 times 10. So we can either use it as a fraction, or if you hit this button above the enter, it'll give you that same fraction as a decimal. So it goes back and forth. So I'm good with either answer. 83.33. Now I don't have a unit. Is this inches? Is it centimeters? Is it miles? I don't really know. So I'm just going to say units cubed. Or I could answer it in a fraction form, 250 divided by 3 units cubed. I'm good with either the decimal or the fraction. It's your choice. All right, and then got another one here with a pyramid. So this is a triangular pyramid because the base of the pyramid is a triangle. So I have a pyramid. So my volume is going to be equal to 1/3 area of the base times the height, and the base is a triangle. And my base is a right triangle, which is super helpful. So I have the 3 sides of the triangle, but I need, for the base of the triangle, the 2 sides that are perpendicular. So I'm going to use 1/3. This is going to be the area of the base. All right, so my base here, the base of the base and the height of the base are 3 and 4. This is going to be 1/2 times 3 times 4. Got a bunch of fractions in here. I'm just going to type into my calculator. And then the height of the whole pyramid always is perpendicular to the base and goes to the top. It is 5 centimeters. So I'm just going to type all this in. The beauty of these calculators that we can put fractions in. So times 3 times 4, close it, times 5, you get 10. So my volume is 10, and I'm going to use my units of centimeters cubed.